Alright, so this is an important idea. It's an application of the dot product. If we look at question 14 here, it says an ice skater exerts a force on his partner as shown. Calculate the work done, increase in energy, by the skater in moving his partner. Alright, so it's an interesting idea. I'm finding it difficult to picture the way that these ice skaters are moving. But here's the partner. Now if we imagine someone comes and pushes that partner, shoves them, and applies 80 newtons of force in this direction, straight across. But because of the way that the ice skater was initially moving, they don't just move in that direction because they weren't standing still. But instead they get deflected and they move in this direction. And they move 6 meters in that direction. Alright, so imagine, if I use another example, you're playing cricket and someone bowls the ball in this direction. Now you might apply a force with your cricket bat because you want to do a straight drive, so you're pushing straight through the ball. But it nicks the edge and it goes in this direction. So a force is being applied in one direction, but it ends up going in a slightly different direction. We're asking how much of this force is transferred into this direction. And to do that, we use the dot product. So you'll remember you have two formulas for the dot product. One of them is the magnitude cosine the angle. So 80 times 6 cosine 32. Calculator time. Alright, so the answer is 407. Now, you're probably looking at that going, wait a minute. 80 newtons in this direction gets transferred into this. But it's not 80 newtons gets transferred here. It gets transferred, this force gets transferred into energy. So it's 407 joules of energy. Alright, so the number is larger, yes, but that's because we're dealing with different units. We're not dealing in newtons, we're dealing in joules here. 407 joules in this direction.